webinar series. Today we have OutBack Power's Kindle Schmidt with us, and he's going to take 45 minutes to go through battery-based grid opportunities. This is part one of a two-part series. This is going to be more relative to sales, while the second part is going to be more of a technical webinar. But as we were just saying, Kindle's going to be going over AC coupling radians, how to offer backup with grid tie, and many more subjects. If you have any questions during the webinar, just post them, and myself or someone here at HS will kindly ask the question on your behalf, either during or at the end of the training. There will be a 15-minute question and answer at the end. And other than that, I think we're going to pass it over to Kindle. Over to you, Kindle.
Oh. Good afternoon, everyone. Thanks for joining us. Just want to jump into kind of what we do best, which is using energy storage with either solar or without, but typically to conquer different utility interaction requirements, or for that matter, a simple NEM system or whatever. Just dive right into it here. First thing I'll touch on is I'll just go through some of the basic block diagrams of how we look at some of these different photovoltaic systems, and some of the pros and cons to each one. Then we'll talk about our pre-wired solutions just as a platform for understanding the whole system. Any of these systems can essentially be custom selected as well, with up to 10 inverters or any number of charge controllers or battery sizes and whatnot. And then I will touch a bit on some of our batteries, just briefly, to give you an idea of some of the lead acid chemistries that are out there and what they're good for. And then we'll take a quick look at our remote monitoring system, monitoring and control system, OpticsRE. So initially, PV direct systems, this is what we would call a DC only system, where you're typically looking at just a battery and a solar panel and then a load. Grid direct is probably what most of you are familiar with. Canada's got quite a booming grid tie economy going, and basically, again, very simple system. Instead of a charge controller on this one, you've just got a grid tie inverter, no batteries involved. And then you've got grid interactive with battery backup, or a grid hybrid system, which is essentially going to be having those batteries in there either for backup situation or energy arbitrage type of situation. And then, of course, off-grid, which is where we cut our teeth and came into this market in the first place 15 years ago. So first, just to understand the basic system, energy flow system for what we've got, your array is making DC wattage. With our system, we're actually keeping that DC power as DC into the batteries. The charge controller is just a DC to DC converter with a bunch of brains in it that helps it to know exactly what current and voltage the batteries need at any particular time. From there, the batteries basically just become a gas tank for our inverter off of. If you imagine it like a pressure tank in a well, that's exactly how we create a perfect sine wave. It's the capacitance of those batteries that allows us to kick out the power that you need in your home. So we'll take a look at grid direct systems. You guys are probably very familiar with this. It is the simplest system that you can put on a roof. You save a bit of cost on batteries. Typically, these do qualify for most state and federal incentives, although we are seeing that change here in the U.S. A couple different states have implemented programs where you need batteries to qualify, or at least need batteries to make it financially feasible. It is also the most efficient solar system. Typically, 5-8 years ago, that was a very important point. I think more and more we're seeing, with the price of panels coming down and the wattage going up, that you're seeing efficiency can often be conquered just by adding a few panels. These type of systems are strictly designed, almost all the time anyway, for economic benefit, just to lower your utility bill and give you a repayment period. The downside, you don't have any backup. So if you've got an emergency, or you've got a critical load or a long-term outage, you don't have anything to back your system up. You can't store that energy to be used later, although essentially in many ways that is what a net metering program is, where the grid is essentially doing your energy storage. And then it doesn't clean up the power. And that's something that a lot of people don't quite understand about our systems, is we kick out a much cleaner sine wave than the utility grid. So any electronics that are on our system are typically going to last longer, depending on your grid, maybe a lot longer. There's some grids that have some pretty significant under voltage type of events, and jumping all over the ANSI limits. So your electronics take the brunt of that. And then the downside as well, many of us in the solar industry can say we don't care if it benefits the power company or not, but in reality, in the long run, we're going to want the utilities, in whatever form they become, to be our partners and to work with us, because there's not another time in all history where there's been a power system like we have in North America or in Europe. So as much as we might hate them, they are still a huge benefit to our overall system, and it would be great if we had something in there that would benefit them to make them like solar systems. That's where OutBack and energy storage come in, because the utilities are extremely interested in energy storage because it helps them to keep costs down and to control the power on their grid. So now I showed you that little block diagram earlier, and you can essentially see the same thing here, but I've added in kind of the pieces that make this whole thing work. So this is a pretty complex system. It's got a generator, it's got an AC panel, it's got battery backup, it's got PV, it's got a sub panel. So essentially what our system is made for in a grid hybrid type of system like this is putting in that backup sub panel. And we get asked all the time, you know, why don't we just back up the main service panel? And the main reason there is just batteries are expensive. So the more you back up, the bigger your battery's got to be, the more cost goes into the system, the more you scare off your customers. The pros with a grid interactive hybrid type of system, you're still lowering your utility bill, so you still get the economic benefit. You are storing the energy locally, so anytime there's an outage or an emergency where you need that power, you've got it. Should you have a long-term outage, we can continue to harvest the solar and back up that critical loads panel, just as if that part of your system was an off-grid system. You know, when you talk essential loads, everybody's got their different ideas, and kind of tongue-in-cheek in this side of the industry, everybody always just says basically, you know, TV, beer fridge, and some lights. But you know, I put systems in for people that need to keep their insulin cold, or you know, lots of things like that. Businesses that are going to lose quite a bit of revenue if their power goes out for an hour or two in the middle of the day. All of these systems still do qualify for any federal or state incentives that are out there, except of course if you're in Ontario and you're part of the feed-in tariff. They did not qualify for that because they wouldn't allow batteries to be installed. This basically is a versatility addition to a solar system, and while the utilities in Canada have not gotten as creative as the ones in the US and Europe so far, I guarantee you it's coming, because all of them are looking at ways to increase their revenue and to kind of mitigate the loss of revenue created by all of the solar installations that have gone in, and they're going to be copycats. So you will see time of use, you will see peak rate structures, you'll see demand charges, if you haven't seen these already, and there's a lot of other ones out there. On the flip side, there are going to be ways the utility will pay you for your energy storage, whether it's just incentives or whether it's legitimately setting up a contract with you where on some signal they require you to dump a certain amount of your battery or to support voltage or frequency on the grid, and those are coming as well. We have systems out there that do that today. So the versatility part of it goes also into the fact that we do know these utilities are going to change their mantra, and when they change the rules, we can change with them. Downsides, it is less efficient. You're probably sacrificing about 5 points of efficiency. So if you're designing these systems, you probably just need to plan on adding another 5% of generation on the roof if possible. There are more components, so you do have a higher initial cost, especially the batteries. And then over time, those batteries do wear out more quickly than the panels, or most of the inverters are going to wear out. and so you do have to plan for the maintenance and replacement of the batteries. Now, a third type of system, one that is becoming more and more important because of all the grid-tied systems that are out there, is AC coupled system, where essentially you've already got a grid-tied system in there, but you want to go add battery backup. Well, people have been doing this ever since grid-tied systems were first put in, but it was very complex, and this is a system that 5-10 years ago somebody would have put in a grid-tied system. Although 10 years ago, come to think of it, there weren't very many grid-tied systems out there. So essentially, if you look here in the middle, you've got your diversion load control. And so when the panels are pumping too much and the batteries can't take it and you can't sell back to the grid, that diversion control would just go ahead and fire up a water heater, heating element, or something where they could dump a bunch of energy. We've actually come up with a much easier way to do this. We do it all internally. We use remote operated circuit breakers and relays inside of a pre-wired load center for the Radian, where essentially as long as the grid is up, we're simply acting as a wire. We're not going to touch that power. All of it just goes straight through to the grid. But if the power goes out, we're basically just going to act like a normal off-grid system, but we're showing a sine wave to that grid tie inverter, so it believes the grid is still there, allowing us to continue to harvest the solar energy, put it in the batteries, power the critical loads panel in the house, and then even if it's at nighttime, just like a normal Radian should, we'll be able to operate off of a battery with or without the grid. I'm not going to dive into the technical part of how those things go together. In our next training, we'll probably get a little deeper, but I'm going to try and whet your appetite on the sales side for understanding what these systems can do and kind of the perspective of the whole ball of wax in terms of the solutions that we offer. And now I'm going to jump into batteries real quick. Just got a few slides to talk about our AGM batteries. If you're watching the trends in the industry, I'm sure you've all heard all about the lithium-ion batteries, the molten salt batteries, fuel cells, saltwater batteries, so on and so forth, along with the traditional wet cell batteries. And for us, the one thing I'll say on that, I could probably go off for 15-20 minutes, but the biggest thing to remember as a battery-based inverter company is we like all of them. Anybody that's going to tell you that one of them is going to be the only one around in 5 years, don't believe them. Essentially, they all have different things that they're good for. And as an inverter manufacturer, we love it because it just opens up a realm of possibilities that in the past we didn't have. As far as what we brought to market, essentially, oh, sorry, I'm talking batteries before I go through this stuff, but essentially we brought to market AGM batteries simply because they were the easiest to use, and trying to couple them up with our pre-wired systems and whatnot made it just a very quick and easy way to have a good battery that we knew what we could tell the customer how long it was going to last, and we could be accurate. So with our systems, we do pre-wired systems. They are cookie cutter. They're not really modifiable. So essentially, if they meet what you need, then they're a great option. If not, you might want to do something like this custom selected system below here, where you buy the components, and this one, for instance, they're flush mounted. It's a different mounting pattern, and obviously made it look really nice inside of a home. And so we give you both options, and essentially go through a couple of these real quick. For those of you that don't know what you're looking at here, I'll just real quick touch on it. This is the inverter. This is the FXR inverter. This is a charge controller, like we saw in that block diagram earlier. This is the Mate 3. This is essentially the brains of the operation. It's where all of the programming goes on, where you get your localized readout in terms of trying to understand what's going on with the system, and kind of it controls all the other pieces. This is a hub. It's just like a networking hub in your computer in your home. A bunch of different devices plug into it, and then they all communicate well. You got a little battery monitor hanging right there on the side. This is your AC wiring panel. There's a little duplex outlet on the side of that one, and this is where all your DC wiring comes in. So essentially, this unit here is single phase only. You can add a little transformer to make it 240, but you're only going to get 3,600 watts of output. It'll surge to about double that, but it's great for, you know, cabins, remote outpasts, so on and so forth, like it says here. Definitely one of the industry standards for just a quick, easy way to go take your cottage that's off-grid on a generator and add a battery system, so you can turn that generator off most of the day and just turn it on when needed to power your batteries up. Flex Power 2, it's basically just double of Flex Power 1, but it does give you 120, 240, 7.2 kilowatts of continuous, or double that for surge, and up to 8,000 watts of solar. I guess I should caveat that with the further north you are, you probably want to start reducing that number on the charge controllers, just because your panels will produce over your STC values. So legitimately 4,000 watts of production per charge controller. I do know that in Northern Ontario, for instance, I've got good installers that are using, say, 3,250 watts is kind of their number that they like to put on one of those. So again, 120, 240, 7.2 kilowatts. My house could probably be powered off of one of these most of the time. As long as you don't have a bunch of resistive loads, this will power most homes. Definitely, we sell a ton of these to our National Forest Service and our National Park Service. So if you're in United States National Parks anyway, these things are in a lot of their buildings. As we get a little bit bigger, we do have a three-phase application pre-wired system. You can see it comes with the 3 charge controllers, 3 inverters, very big DC and AC load panels, and this is a 12208 out of the box. If you do need a different power of three-phase power, you'll have to get transformers on the input and the output. But you can also stack up to 9 of these for up to a 32.4 kilowatt of continuous, or up to 65 kilowatts of surge. So really good for commercial systems. In the US, especially where the utilities are getting very creative with their billing mechanisms, we've used these quite a bit in small commercial places just to cut their power bill down, and you don't even have to cover much of their power requirement to do it. A lot of times with things like demand charges and peak charges, we can just take away those portions of the bill that are really onerous and leave the rest of their systems just on the grid when it makes sense. And then our big guy, so 14.4 kilowatts of continuous, or 28 kilowatts of surge. You can also get large like this using Radians, but for a pre-wired system, if you have a really big load, this is a great way to go. And then recently we did start selling our Radians pre-wired as well. So this can be an 8 or a 4 kilowatt unit. It is 120, 240 out of the box. We do have European voltages and whatnot in all of these if any of you work overseas. And this guy is pretty slick, actually. I have this in my house. The installation time is about a day less than if you would have bought the components and put them in separately. So it saves you a bunch of time right there. The FXR, this is our new line based on the FX product that has been around since 2000. Essentially, all we did was add in a couple different pieces that we had already added to the Radian. There's a mode called Grid Zero in here that we'll talk a little bit more about later, and then also have opened up our battery charging parameters to work with a lot of those advanced chemistries that you're hearing so much about in the news. Some of the big things that changed with this guy, the operating efficiency went up from 90 to 93. We do the power factor corrected battery charging, and then for me, I've been the voice at OutBack for bigger 3-phase capabilities, and previous to this we could only do 3-phase off-grid. We can do 9 of these in a grid-tied 3-phase system. So it's a huge benefit, and almost no matter where you are and what your utility says, there's ways that you can use a system like that to reduce costs. The Radian, basically, 2 power modules in the 8, 1 in the 4. It's a 4,000 watt power module. It does have great surge capacity. You can put up to 10 of them in a system. You can mix up to 8s and 4s. So if you've got a number to hit that's based on any any multiple of 4. You can do it up to 80 kilowatts. It does have the capability of accepting dual AC inputs, so you can put a generator in a system that is connected to the grid if you have supercritical loads that you want to make sure you always have backed up. And then the difference between the old Radian, the new Radian, the FXR, and the old FX really is just that the motherboard and the processor that are in there are capable of doing way more than they were in the old stuff. And it's essentially the platform for the new grid or the smart grid that's coming. We know what's coming to a certain extent just because the utilities do continue to copy each other. And so we've developed the smarts that are needed to work with the new grid today. They're in there. When you need them, they'll be ready for you. So again, relying on that versatility that our stuff brings to the market, that when the rules change, we can change with it. So I want to spend a little bit of time talking about the modes and a couple of different operations that we can do, and just kind of, I'll first explain them to you, but then we'll talk a little bit about the way that we've seen these in utility interactive systems and what sort of capabilities they bring. So Grid Zero is essentially, it was initially, we came up with it for island communities where the grid gets saturated with solar and they say they can't accept any more solar pumping onto the grid. And so Grid Zero basically allows you to maximize the use of the solar that's on your roof, never sell back to the grid, but maintain your connection to the grid so that if you have any big loads or surges, we can leave those for the grid to pick up, and meanwhile just use everything else that we can on the solar and the batteries. Generator mode basically just accepts power from a low quality sine wave. So if you got a cheap generator, our system doesn't want to look at that sine wave, so basically generator just says, hey, inverter, close your eyes, don't look at this sine wave, it's really ugly, it'll make you cry. And we just become a wire again. We pass that ugly power through to the loads, which is not the greatest thing, but it will allow you to charge your batteries, so when you're stuck, you know, and don't have much sun, you can go ahead and get those things charged up. Support mode augments another AC source with limited output. There's a bunch of different ways that this can be used in a utility interactive system. Traditionally, this was originally meant for someone who had bought a big generator but then added loads and needed a little bit more power, so it was just a way to take a battery system and augment that. But as the utilities have gotten creative, this turned into a really good mode. Grid tied mode is the one that you guys are all familiar with. Basically, we're selling every watt back that we can to the utility and buying everything from the utility to power the loads. But with our systems, of course, you do have some backup in there as well. Backup is going to be essentially never selling anything to the grid. The system is just sitting there waiting for the power to go out so that it can back it up. The one kind of big thing with backup is that it is going to always maintain your batteries at the 100% peak level, whereas if you're in grid tied, you know, they may actually fluctuate just a little bit. It's not always, the priority is not battery power in a grid tied system. Mini grid, it's somewhat similar to Grid Zero. It acts like it's off grid, but at the same time, when the batteries do get low, it will tap into the grid to recharge the batteries and power the loads. But it's an all or nothing thing. So if you're on mini grid, it's basically just going to run on solar and batteries, but you hit that low voltage disconnect and immediately it shifts everything over to the grid, so you're not blending or anything like that. So now let's talk a little bit about how these are used. So Grid Zero, restricted circuits. So if you've got a saturated circuit, utility says you can't sell back, that's kind of the big one. If there's no value in selling back, in Hawaii, for instance, right now, they've gone to a retail wholesale rate structure where when you sell something back to the utility, you're basically getting half price for it. And so you would prefer to keep it in your batteries and use it yourself. And then the third one is solar taxation. There's systems that are in Arizona, for instance, where if you connect the solar system in parallel with the grid, you are charged $70 a month as a flat fee no matter what. Even if your bill is zero, your bill would be $70 a month. So what you can do with a Grid Zero type of system is you can pull that that critical loads panel, you can pull the grid through the critical loads panel and run all of those loads off of your grid zero system, and you're still backed up in case you don't have solar production or your batteries get too low, because you do have the grid capable of coming in, but you're never in parallel with the grid because you're not connecting to the main meter or anything like that. Generator, again, just you got a $500 Costco generator with an ugly sine wave. We just allow it to go through to the loads and charge the batteries. Not necessarily a bunch of different applications there that's used in strictly with those bad generators. Support mode is another really good one. It can be used for peak shaving, demand charge reduction, or augmenting a weak AC source like I mentioned. So let's talk just for a second about some of these things. In California, for instance, a lot of different places actually, but California has some really high demand charge rates. And essentially the utility is saying, if I'm going to have you capable of hitting me with that demand at any one point in time, then I have to charge you for that, because I've basically got to keep my spinning reserves going to make sure that I can give you the power that's needed right when you need it. Well, if the way that California and most of them will do that is you have some sort of charge based on a momentary demand of kilowatts. So let's say the demand charge is $17 per kilowatt. They take your highest demand for the month and they multiply that out. So let's just say your highest demand for the month is 100 kilowatts. You're going to be charged $1,700 every month just for your demand charges. There's a bunch of other ways that they use demand charges as well. They calculate them in about 1 million different confusing ways just to make it hard to get your head around. But some of these demand charges that I've seen will actually, they'll figure out what your highest demand is in the previous 12 months, and then you will pay based on a rate schedule that's built around that demand in the previous. That will define your rate for the next 12 months. In cases like that, there can easily be half or more of the bill can be demand charges. When I talk about peak shaving, now essentially what support mode can do as well is take whatever size system you have and maximize its capability. So let's say that you have a base load of 15 kilowatts. Well, if we put your system into support mode and say you're getting charged at the peak rate from noon until 6 in the evening, we can essentially tell your system to support that base load and anything over that base load to the tune of whatever number of amps you wanted to support it. Basically, you would figure out what your battery system is capable of with your solar system and your inverter, and just give it that number of amps, and it'll keep the current from the utility below that number of amps, so essentially shaving off some of those peak demand charges. Grid tied, this is just the normal NEM or feed-in tariff type of system, but you do have the backup there. Backup, again, is strictly for critical loads. Mini grid, basically acting like an off-grid system, but using the grid when the batteries get low. Typically, mini grid is something that you would use if you have extremely high rates from your utility. I know that you guys do have some places like that, especially if you start looking at the Hydro One and their crazy structures where they try and make you think you're paying 11 to 14 cents a kilowatt hour, and you roll in all the debt reduction charges for your nuclear facility and so on and so forth, and you see 22 to 28 cents a kilowatt hour. Not to mention you get further out and you've got the delivery charges. So there's definitely places where mini grid or grid zero are going to make sense in Canada, but also I'd welcome I'd say take a look at any of the predictions on prices going up, and every one of your utilities has some percentage markup that they're expecting over the next 10 years. I also threw in HPX, or high battery transfer, in here. It's not a mode, it's an application that exists within the Mate 3, and it can be attached to quite a few different modes. But essentially what it does is when it tells the system that when your battery hits a certain point of being charged, that you essentially just want to disconnect the critical loads panel. So it just allows you to essentially use whatever battery capacity you have to support the loads that are on the critical loads panel. So just real quick review here. The advanced models are the GS4048, 8048, 3548, and 7048. We did have a GS8048 without the A on there. We still do sell that, but at the end of this year that will be discontinued. So all of these have grid zero in them. They can all accept advanced energy storage and work with most of the new chemistries of batteries. They all do have all 7 modes now. The 2 AC input options are strictly on the Radians. We do have pre-wired load centers for the Radians. Anything from, you know, a completely empty box to one that's got your main breakers and bus bars, all the way up to something that's pre-wired for 1 or 2 charge controllers, as well as that AC coupled pre-wired system. So this one here is actually more for your review after I send this out to Ed and team and they pass it on to you. But this just has all of our AC input modes here, along with just kind of what they do and why. I guarantee you, as you start looking at your utilities rate structures over the next couple of years, even now, but as things change, these different ways of being versatile are going to really matter to your customers. So good idea to get acquainted with them, and if you have some questions, we're always glad to help, and HES knows these systems really well as well. Sorry, I'm going to skip that one. We'll talk just real quickly here. I want to talk about grid zero. It's kind of a tough one to get your head around at first, even though it actually is pretty simple. I'm pretty dense, so it took me a long time, but this graph really helps me out. Essentially, this dark line here is your load. The blue line underneath of it here is your battery-based system, and the 10 amps here is a set point that you put in. You don't ever want to pull more than 10 amps out of your battery system, and this is your low voltage disconnect. For this one, set at 48 volts, so keeping it relatively high on that battery system. And then this line down here is the grid. So essentially, as that load goes up, we see a surge. We hit that 10 amps. We've already told our system that we don't want it pulling anything over that 10 amps from the battery system, and so it grabs from the grid and it combines to power that load. As the load keeps going, the surge goes away, it levels out, but we're still running our battery. Obviously, you know, not too big of a battery because it's losing its voltage quickly. As we get down towards the low battery cutout, we're basically over here. You see, as your voltage drops down to 48, the utility power picks up and trades off with the inverter power. So hope that helps to explain it. The one other thing that's interesting here is you notice the utility is never pulling zero. We call it grid zero because marketing came up with the name, but we're always pulling the first amp from the utility. It's a little bit of a misnomer in that you're never going to zero out the grid with this one. If you really do want to zero out the grid, HBX or mini grid with a properly sized battery system and a properly sized inverter is the way that you go about doing that. So now, I know I teased it a minute ago, but I'll go through just a couple slides of our batteries just so you understand, you know, the real basic lead acid chemistries that are out there. And of course, on your own, you can delve into all the new advanced chemistries that are out there as well. In our RE battery, this is just a basic cycling battery. Our parent company has about 40 years of experience with this battery, so we field tested this in cable and telecom sites all over the world, so it's not like we're just bringing this to market and private labeling it. We know it really well. We go anywhere from a real small 34 amp hour size all the way up to 2700 amp hours in a 2-volt system. So we've got little top terminal group 31s, front terminals, and then these big rack systems. With any of our systems with the appropriate rack, they ship complete. The only thing you need is your home runs, all of your interconnects, your racking, shunting, overcurrent protection, etc., is involved in all of our rack systems. So the second type of chemistry is the nanocarbon. This is relatively recent for us to pick up, but essentially what you have here is molecular carbon bonded to the lead within the plates, and this is a partial state of charge specialist. So essentially this does not need to be recharged every day, and in fact it doesn't like to. The best operation for this guy is to operate between like 35 and 85% state of charge. If you do that, you increase your cycle life by about 40–45% and still getting the same amount out of your battery every day. But one of the really cool things is, since you're not going through a full absorb and float cycle, is you improve your efficiency, and so your round trip efficiency on these is just as good or better than most of the top lithium ion batteries as well. Great for off-grid. Anybody that does off-grid understands that partial state of charge is just a way of life. You go out there once a week and you turn your generator on to put it through a full charge. These guys don't need to go through a full charge except every 3 months. So, and they gain operation by going that way. And then this is our backup specialist. This is a float battery. So there's two types of life in a battery. You have your calendar life and you have your cycle life. Cycle life is the one that we're most experienced with. Everybody talks about it. You know, I can get this many cycles at a 50% depth of discharge. Well, this has a terrible cycle life. It has 750 cycles at 50% in it. But meanwhile, it's got an immense calendar life. So that's why it's a backup specialist. This will last about 16 years in a float system and still maintain 80% of its life. A typical AGM battery, even if it's barely used and it's just exercise, kept in a perfect temperature controlled environment, you're going to be maxing it out, 10 years might even be a long time. So you get a few extra years out of these guys. And one other big benefit with these guys, especially on an AC coupled system, is they can accept much more current than any of those other batteries. You can put a smaller battery bank in with a bigger array. So if you've got somebody that just wants to add a little bit of backup, they don't necessarily want to size their battery to their array. This is a great way to reduce the size and the cost of that battery bank and still give them the backup that they need. So just a quick pictorial look at our whole setup. We've got the front terminals, and all three of those, they match up with the IBR racks. The high capacity stuff comes racks included. And then our top terminal stuff, we've got a series of racking systems and cabinets, indoor and outdoor, for those guys as well. All right, so I'm actually going to bounce onto our website here and go through just a quick tutorial on OpticsRE, about 5–10 minutes here, and then we'll open it up for some questions. So when you first go to OpticsRE, you guys could go there now and you could actually demo the system and drive around a little bit. But when you've got systems on here, this, as an installer, this is how it would open up. And if you have, let's say you're in Saskatchewan, it would automatically scale to where your systems are. So let's say you've got somebody up here in North Battleford, somebody in Regina, so on and so forth. It's not going to show you the whole world. It's just going to automatically scale to those. Go and look at these systems. If they're black like this, that means there's nothing wrong. They're going great. If they're yellow, it means you need to take a quick look, and it usually means there's an event. If there's an AC outage, you'll see a yellow icon there. And if it's red, it means there's a warning or an error. You can also set these up so that you can receive email or text alerts. So basically, now you're in the system. So if you're an installer, you're setting these up. You're not having your customer set them up. There's far too much control in here. And what you do is you actually set it up and then invite your customer to just this dashboard only, so that this is what they're looking at. Get your little dashboard. It's kind of, pretty little explanation of your energy flow. Quick snapshot of what's going on at the moment. You can manipulate this by the day all the way up to 5 years for aggregated effect. And then down below, you've got a million different ways that you can graph this thing. You can add in and add out these different pieces here. if you want to just look at your solar production, so on and so forth. And this is a system view. We can dive into the individual view so we can see what our inverters were doing. You know, buying from the grid to the critical loads panel, selling to the grid here, obviously a decent production day so far. And then you can go into your charge controllers. Right now on this system, the 3 charge controllers, it's showing them aggregated. You can actually break those up so that they're 1, 2, and 3. And then another interesting thing is you can just go back and take a look at historical data. So you can see, you know, week by week, day by day, whatever it might be. You can go all the way back, and I don't think this system's been in there that long, but we can take a quick look at the year. And obviously, we get some pretty good production here. And then, of course, your battery, you can look at it state of charge. If you've got a FNDC in the system, you can look at it by voltage. And you can also look at it temperature compensated. So that's the dashboard, and that's essentially, you know, that's the stuff that you sell to your customers. They sell to their friends. They can do all this on their phone, on their iPad, whatever, anywhere they can get an internet signal. And then for a installer managing the system, there's some great pieces as well. There's 600 attributes that you can control on here. So a lot of times you're actually finding out about any little nuance with the system before the customer, fixing it offline or fixing it you know, without going to the site, and then telling the customer, hey, this is what I did. So a couple different things here. You can add pictures of the site. So if you got 100 different installations, easy enough to remember it when you go there. You can add notes on the alerts. This is where you go in and you decide what alerts you want to be notified of and how. And there's lots and lots of these, a couple hundred, I believe, that you can set up. You can go on to and manage the devices. So just a quick look at everything, where the firmware is. Today, you still have to do the firmware manually, taking an SD card to the site and uploading it. In the future, you will be able to just push the updates to the system remotely. So let's go back to the main screen here. So another part of this is you're going to go into your device map. And so one of the things that a lot of people are really excited about here is the fact that when you go on site, no more do you have to sit there and move that little wheel and up and down menus on your Mate 3. You have an SD card that has, you know, basic parameters. You download them into the Mate 3. You come back to your computer in your house. You set up the Optics system, and you go and you program your automatic generator start, grid use timers, just lots of different things. This is where you can play with your HVX mode. You can change what mode of operation you're in. Flex time is a really interesting one. You can actually tell your system to change its mode of operation up to 3 times a day. So let's say that you've got peak charges between noon and 6, and you've got really cheap utility rates in the middle of the night. You may tell your system, go ahead and be grid tied in the middle of the night, charge that battery all the way up, but then I want you all the way off grid come noon until 6. There's a bunch of different pieces here for like AC coupling. Global charge controller is a really interesting one. If you have several different charge controllers, you can make sure that they're all working together. A couple of the ones that are exciting as well is your battery programming. So when you're talking about setting up battery charging and you're using little dials and whatnot, think about all the time you're going to save when you just have these bars and you're just pushing it with your mouse to the right absorb, the right amount of time, so on and so forth. All your voltage and intervals can be set up in here. And so this is all remote. So this is you at home with a beer in front of your computer, not at the site, tired, trying to figure out how to program this thing, trying to get on the phone with tech support if you got a question. So it definitely makes it a lot easier. The whole entire goal of Optics is to save time for the installers. So keep in mind, like I said right up the top, don't let your customer set this up. This is a tool for you. This is some fluff and some marketing and, you know, a friendly little application for your customer to be able to look at some things. But as an installer, this is a way that you don't have to get your truck on the road every time there's some little problem with the site. You can get a lot more knowledge out of here. And the other big thing is you can call into tech support. You can tell them the name of the system. You can have them log in, and they can walk you through any of your questions with everything right in front of you, right in front of them. I tell the story about how often tech support used to be walking around with their eyes closed, thinking about things because they're going through visually in their head what the installer is asking them about. And anymore, they're just sitting there looking at exactly the same thing as you. So it makes things a lot easier. And really, that's my presentation in a nutshell for now. So let's see if there's some questions here, and go ahead and answer them.
Okay. I think you're on mute. Thanks, Kindle. I don't know if you can hear me.
I can hear you. Yeah, I barely heard somebody in the background, but I didn't catch the question.
All right, perfect. Well, thanks, Kindle, first off, for the presentation. And yes, there are some questions here. Brian Deggs is going to help with those in a moment. So while we're just talking right now, if there are questions, please start typing them in now, and we'll answer them in an orderly fashion. Brian, are you still there? No. All right, well, I'm just going to jump in here. Jeff Jackman had asked a quick question. When in grid zero, are the batteries used only on essential load panel?
Yes, yeah, always with these types of systems, the batteries are only going to be used on the critical loads panel unless you do, there's a couple different ways you can do like a whole house backup, but for the most part, that's the most standard way to do it.
Oh.
Hello?
Hello, I'm here. Did you lose me?
Yeah, sorry, we're just cutting in and out here. Hold on 1 second.
Oh, I'm sorry.
So there's another question, and it's basically how you can add microinverters into your system.
Okay, yeah, I mean, basically very easy to do with the AC coupled system. So if it's strictly for backup and you just want to sell everything you can to the grid, you buy a Radian with a pre-wired load center, a Mate 3, and a battery bank, and it's legitimately connecting your positive, your negative, and your two neutrals from your grid tie inverter to bus bars that are all pre-wired in the load center, wiring in your battery bank, and then it takes 5 button pushes to enable AC coupling on the Mate 3. The caveat is there can be a little bit of dialing in of voltages and stuff that may need done afterwards, but really, really simple system. And I'll let these guys give you some pricing, but nominal cost for adding a small amount of backup to a system that's already microinverters or a string inverter.
Another question, just if you had any future of 24-volt support. I know that it's not as efficient, but yeah, just wondering if that was something that was in the future or if you're sticking with 48-volt.
Well, we will continue to always support 24 and 12-volt systems with the FXR. So the FXR does have 12, 24 volt systems as well as sealed and vented inverters. I mean, we've got a customer with over 1,000 units deployed worldwide in like every one of the deepest, darkest jungles around, and they're always using the 12-volt systems because when you're talking about hiking batteries into those places, they want to take as minimal amount of a battery as they can. Meanwhile, 48-volt is more efficient, and so the industry overall is moving that way, but you'll never entirely lose the 12 and 24-volt world. So we'll have the FXR to meet that need for as long as it's forever, really.
Okay, we have another client looking for a little further, I guess a brief overview, quick explanation of the HBX mode.
Okay, so yeah, basically it's just telling your system whenever the battery is fully charged, I want you to clip off the utility and go onto the battery until you get to such and such a point of a low voltage disconnect or a state of charge, and then go ahead and head back over to the utility, charge it up either from the utility or the renewables. You can tell it to not use the utility to charge if you'd like, and then once it's charged again, clips you back off. So it's really just a way to reduce the use of the utility, typically used in places with high power bills.
Another quick question is OpticsRE, just making sure that it is remotely accessible as opposed to needing an SD card on site to communicate with it.
Not totally understanding what you mean there, but you don't need the SD card on site to use Optics. It resides in the Mate 3 or the access port. It's free with any of our systems, but the one piece that I was saying at that point that might have confused somebody is today, to update firmware, you still have to actually go on site with an SD card with the new firmware on it. But by the end of this year, it'll be like your cell phone or anything else where it'll say updates available for the Radian or whatever, and right from your phone within Optics, you can just say, go ahead and update all or whatever it might be, and it'll update the firmware to the latest.
Okay. When in Grid 0, do you require LDC permission to connect?
It really depends. Essentially, the way that the laws are written, if you're not selling back to the utility and you're on the customer side of the meter, you're not officially interconnected. However, utilities all over the place will gladly write their rules such that you have to tell them, and in fact maybe apply for an interconnection in order to do that. The best way for me to kind of delve into that realm a little bit is to bring up Hawaii one more time. It's one of the more complex utility interactive environments in the world, and basically we went through a period of the last couple years with them where the HCA group, the Solar Industry Association there, was trying to get HECO to admit that you did not need an interconnection study done to be off-grid. And HECO sat there and legitimately told everybody that you had to get an interconnection permit and a study done, which they charged $1,700 to $2,500 for, to be off-grid. Now, people got around that in a variety of ways, and now we're finally at a point where the PUC has put their foot down. And in fact, the PUC had them write in particular language on this last ruling where a Grid 0 type of system, or they call it a zero feedback type of system, you don't even apply for anything. You actually file a form with the utility saying, I'm putting this system in. This is essentially just efficiency measures on my home. So it's a battle that's continuing to be played out. I mean, I brought up Arizona. If you put that system in Arizona, same thing. Officially, you're not operating in parallel with the grid, but the APS, the Arizona Power System, will try and tell you that you need to pay $70 a month to have a solar system connected to their grid.
Another quick tech question. Will the Mate 1 or 2 work with any of the R or Radian systems?
No,
FXR or R?
And actually, you should be overjoyed, whoever asked that question, if you played with the Mate or the Mate B or the Mate 2. The Mate 3 is so much better, and it's still not perfect, but Optics takes all that just to a new level. No more of these 150 command strings that you've got to go through, and it just makes it much easier to get away from those anyway.
Okay, there's a bunch of other questions that are either specific, technical, or dealing with competitor products. So I'm going to take some of those offline, and let me just pass it back for Cameron for the outro. But do email in if your question was not covered, and we will try to get an answer for that.
Yeah, and just one more thing there too. I mean, if you're joining us next time for when we get a little more technical on this thing, If you've got technical questions that you want to make sure that we hit on, let Brian know, and he can clue me in on those, and we'll build that into the presentation.
Perfect. Yeah, absolutely. Just let us know about any questions you might have. Round 2 of the webinar is going to be happening mid to late May, and we still have to organize that with Kindle. But check your emails. We will be sending out some bulletins along the way. So yeah, just keep following your emails to see when that's actually going to be taking place. Otherwise, thank you everybody for coming in today. Thank you very much, Kindle, as well. Great presentation. Really appreciate it.
Thank you.
Again, everyone have a great day, and if you have some questions, feel free to send them in, and we'll field them either through email or again through the second part of this this webinar series. Thanks again. Take care, everyone.